Welcome to video 8 phase changes. In this video, you're going to be explaining the different phase changes that occur between the different states of matter, primarily liquid, solid, and gas. In this video, you're also going to learn how to evaluate a phase diagram and read a phase change graph. As we get started, you will see there are a handful of definitions that you need to be aware of. Again, this is a heavy definition vocab chapter, so make sure you're putting in the time to review these and check Quizlet. So as we get started, let me read these through to you, and then we'll get going. We have melting, sublimation, freezing, vaporization, condensation, deposition, phase diagram, triple point, and critical point. So a phase change. We already know the three primary phases are solid, liquids, and gas. And so a phase change is whenever a substance or a chemical or even an element or some kind of compound changes between one phase to the other one. And depending on the direction, will depend on how it gets labeled. And also when we do this, we need to consider the temperature and pressure being applied. So here we can see this small little picture. This is the enthalpy of the system. Enthalpy really is just the amount of internal energy. So think of enthalpy as energy, but it does consider the pressure and volume of what you're working with. And again, you can see the definitions here that I'm about to read to you on the next page. So as we get going, melting is simply going from a solid to a liquid, which you already know. Sublimation is going from solid straight to a gas. Freezing is going from a liquid to solid. Vaporization is going from a liquid to a gas. Condensation is going from gas to a liquid. Think of the condensation on your window. Think of condensation in your refrigerator. And then deposition is going from a gas to a solid. So again, you can see some of these are the opposite of each other. Some skip phases in the middle. Like I said, it's important that you are very comfortable with these terms as we move through this video and through this unit. So here is a graph of a phase change. Here we see that this graph is showing the energy and how it changes and how it affects water. So remember, every energy in a system is directly related to temperature. So when we look at these, notice that these are all about temperature. Now pressure does play a role in this, and typically on a graph like this, pressure will be stated somewhere in the corner like at 1 atmospheric pressure or so-and-so. But if you don't see a pressure, assume it's at 1 atmosphere. But again, here's a diagram or a graph that you have to be able to read. We see here at the bottom, it's the amount of heat added, which you've already learned that in the kinetic worker theory, that heat added and temperature is really going to change the kinetic energy. When we talk about temperature, we're really changing the kinetic energy of the molecules, the movement of the molecules on the inside. And so here in this first dotted section is going to be our solids. In the next video, I will teach you what these symbols mean. These are the equations actually to calculate this right here. But however, the first group here, or the first block is solid. Then we have what's called a phase change. You will notice that the energy here is increasing. So we're putting energy into the system, we're adding heat, thermal energy in other words. The kinetic energy, or what we refer to as the temperature, is increasing. And when we get to this point of 0 degrees Celsius, we actually have a stall where the system or where the water will not increase in temperature. However, all that thermal energy going into it is allowing it to change from a solid to a liquid. So we have this little gap here where water is going to be existing both as a solid and a liquid until enough energy has hit all the water molecules to turn them all into a liquid. So then again, we have this another phase of liquid right here, and we put in so much energy, we put in so much thermal heat to get this raised up. And then again, we're going to find this little plateau here where there's going to be more energy going to the system, but the temperature is going to stay the same because in this process, the gas will be changing from a liquid, and so it's going back and forth until we get enough energy in the system and it finally turns into a gas. And remember up here, you can see the particles showing you what's going on as they change these systems. So again, pretty simple graph. You just need to be able to read the temperature and understand that here temperature is increasing, here temperature is stable, while we are converting all the molecules from one phase to the next. The next phase diagram is, again, something you've probably seen before, but a phase diagram just shows you the different states of matter at different temperature and pressure. So on the bottom x-axis, we have the temperature. On the y-axis, we have the pressure. And we see at some graph point, which I'll give you these in your homework, you need to be able to read and tell me what phase a certain substance is. So let's see here. This right here, inside or to the left of this green curved line here, this is what we're going to call the solid phase. So if I have a temperature and a pressure of a substance that falls in this area, we would know it's a solid. If that data point falls in this area right here, we would know it's a liquid. If it falls in this area here, it would be a gas. And so you will actually see a phase diagram like this for each individual chemical that you would deal with, because every chemical is slightly different. So again, our lines represent phase changes. We can see here that we have two other major points on this phase diagram. One is called the triple point. This is a really cool, really unique point in time where when the temperature and the pressure are right, you can actually have all three phases of a substance exist at one time. So right here at this given temperature and pressure, a substance can be a liquid, solid, and a gas all at one time. And then we also have what's called the critical point. The critical point up here is when you are at the highest pressure and the highest temperature that a liquid can exist in. So once I get to this point, beyond here, a substance cannot be a liquid anymore. It will either be a gas or will be what we call a supercritical fluid. So again, a critical point gives you basically the highest point in which a substance can exist as a liquid. It goes any warmer, it goes any higher pressure, it does not become a liquid anymore, it starts to behave differently. So really that's it. This video is short and sweet. I want you again to make sure you are spending time understanding these phase changes. Make sure you do take a second to rewatch this part if you did not get the concept of the phase graph, which should be pretty straightforward, or the phase diagram. But really, long story short, phase changes are common and they require a change in energy for the chemicals to make those jumps. Phase diagrams help us explain the state of matter and why it's a different state of matter at different temperature and pressures. So that's it. Have a great day.